Today we'll talk about a technical comparison of Organica's food chain reactor, commonly referred to as FCR, to conventional activated sludge processes. These conventional activated sludge processes are the process and the treatment configuration that most people commonly think about when they think about wastewater treatment process, and they've been employed for 90 or 100 years now, commonly around the world. They all rely on suspended growth of biological bacteria and organisms that consume waste. The suspended growth simply means that the organisms are free-floating in liquid, and so therefore suspended in the liquid column. And they typically operate in the range of 2,000 to 5,000 milligrams per liter of biomass that's suspended and lives in that liquid. And if you look at a conventional activated sludge process diagram, once the flow enters the treatment facility, it has pre-treatment, which would typically be screens and in some cases primary clarifiers, followed by the biological treatment process or aeration basins where the suspended mixed liquor organisms reside. Following treatment in that aeration basin, they will be sent to a clarifier where the organisms gravity settle out in that clarifier. And a fraction of these organisms that settle in the clarifier are then recycled back into the biological process to make sure there's enough biological activity, and that's the RAS, return activated sludge. The other fraction then is sent off for solids processing, which we won't get into in much detail here. But these clarifiers then separate the solids from the liquid before the liquid is discharged. So if you look at the conventional activated sludge operating parameters, again you have suspended solids, mixed liquor suspended solids, MLSS of 2,000 to 3,000 typically. Typically we see about 800 species in a biological process of this configuration, and due to the suspended growth organisms and the solids in the system, the viscosity of the liquid changes and decreases alpha factor, which is simply a measure of how efficient the oxygen transfers into the liquid. So that typically would be in the range of 0.5 to 0.65. The RAS rate, again that's the recycled mixed liquor, is typically going to be 25 to 50% of the flow through the facility. Most of these are set up in complete mix reactors with a single reactor zone completely mixed and operated as sludge age or SRT of 5 to 10 days, and that'll become important as I talk a little bit about the FCR, resulting in a sludge production rate, and we'll talk about that comparison towards the end. So then if we look at the FCR, it is an IFAS solution, IFAS meaning integrated fixed film activated sludge, and it uses attached growth organisms. These attached growth organisms attach to both plant roots as well as engineered biofiber media in the FCR reactor that allows increased biomass concentrations. It also reduces the suspended solids concentrations by 90% or more relative to the conventional systems we talked about already. But many of the organisms that are utilized in these processes are similar to both activated sludge processes as well as traditional fixed film processes such as RBCs that you may be familiar with. So if we look at the FCR reactor as the heart of the solution, again a conventional process would have roughly 800 species and 2,000 to 3,000 milligrams per liter of biomass in the system. We generate this attached growth biomass by placing plant racks into the reactor, and therefore the plant roots grow down into the reactor. We don't actually rely on the plants to do the treatment, but the plant roots become a surface area for the fixed film growth to occur. Now, unfortunately, the plants can only grow so deep, typically about 1.5 meters into the reactor. And as a result, we have to place some engineered plant roots into the reactor as well. So this engineered biofiber media is designed to simulate a plant root as much as possible, but allows us to make the reactors deeper and therefore more space and energy efficient. But as you see, the plant roots generate a symbiotic relationship with the biomass. It increases the diversity of the biomass to about 3,000 species in the reactor, significantly more than the conventional processes. Now, the FCR reactors are also broken into separate and distinctive zones as the liquid moves through the process. Typically, it's 6 zones. And so with the biomass attached into these zones, the biomass becomes resident to each reactor zone and therefore stays in the loading conditions and oxygen levels that are present in that zone. And so the biomass naturally selects, and the more effective organisms that operate under those conditions stay resident in that to optimize the treatment process with the organisms that are best suited to those conditions. So if you look at a speciation across each of the reactor zones, which we've done, you'll see differences based on the loading rates in the zone, the nutrient content, the dissolved oxygen content, and other variables that allow the species best adapted to that condition to proliferate and therefore become predominant in the system. So in a very simplified process scheme, the FCR will replace the aeration basin with the FCR reactors. Again, high biomass density, so typically around 10 milligram per liter of biomass density, but very little of that is suspended. So the mixed liquor solids is typically going to be around 100 to 300 in suspension. And then we also, with the FCR, because we don't want to proliferate those organisms that are suspended returning back to the reactors, we eliminate the RAS, or the return activated sludge line. Many of our facilities still use clarifiers to separate any excess biomass that washes off the fixed film in a clarifier, but because of the low solids concentration, we can also utilize a disc filter directly after the FCR reactors to separate the solids. That saves space, but also provides a positive barrier for any solids leaving the system. So that elimination of the RAS stops the proliferation of the suspended growth organisms because they don't get returned to the reactor, but it also extends the effective sludge age of the biomass in the system. That longer SRT becomes important as it reduces the sludge production coming out of the system. And it also simplifies the operation with one less variable to manage in the process. So again, lower solids concentrations allows the use of a disc filter in place of a clarifier to save space. If you look at the key differences then, just to summarize, we use attached growth versus suspended growth in the FCR. We increase the biomass density and diversity. We utilize specialized reactor zones to optimize the ecology to the local operating conditions. And the lower suspended solids, it does two things. One is improving alpha in the reactor, but also allowing the use of filtration disc filters as the secondary phase separation. And then the elimination of the RAS extends the sludge age, which reduces sludge production, but also simplifies operation. So as you can see here, here's a simple comparison of the conventional activated sludge to FCR operational conditions for each of those criteria we mentioned previously. We'll have a separate video sequence that will talk about the benefits of each of these things in more detail following.